Yes. To honor Rosella, who's not here, I wear this wig, but I'm going to take it off now. From Safespring, Gabriel. And what we're going to do today is that we're going to demo a live setup of the container as a service platform from SUSE on the Safespring cloud. And that's going to be totally live, so we are actually challenging the demo gods here. So we're going to see how that goes, and we think it's going to be awesome. Yes.
So this is not a demo on Kubernetes itself. It's a demo on our Kubernetes distribution, container as a service platform from SUSE. So we will provision the servers in Safespring's OpenStack environment, and we will manually configure the container as a service platform. And then we will deploy a service in Kubernetes. After that, we will grow the cluster with an additional node, and then expand the service to span over all the nodes, and do a presentation of Safespring and a short presentation of SUSE, all within 35 minutes.
Yes.
So hold on.
Let's get going.
So, as you can see, we logged into Safespring's Horizon, and we actually have an instance already running there. It's just a DNS server. Kubernetes needs a working network environment, so it's all what it's providing. So I actually created a script for deploying the instances in OpenStack, within Safespring's OpenStack. You could use a heat template. We do provide a heat template. We have not used that in this demo because you could deploy the container as a service platform on physical hardware as well. So we want to show actually how it's done. So let's just. Oh, sorry, cat. As you can see, the script that I'm using is just OpenStack client. So instead of clicking within Horizon, I actually script this. So let's just launch that script and let it work in the background, and you will see that there will be instances
Popping up.
So they are spawning. While those are booting up and building, I wanted to know who Safespring is. So we have a couple of minutes for that.
Yes, Safespring is a local service provider in the OpenStack environment. We have worked very much towards the academic sector. So we have a lot of customers in that area. And we have data centers, 2 data centers in Stockholm, one north and one south, with interaction and with IP only. And then also we have a Norwegian presence, so we have a data center as well in Oslo, which is also IP only. So what services do we provide? We provide backup, which is a cloud-based multi-tenant backup solution. That is actually the only solution that is not open source. We use IBM, TSM, Spectrum Protect, and to minimize the manual management for the customers. We have a compute platform built on OpenStack, of course. That's why we're here. And also storage solution. We both provide the object storage for the OpenStack with Ceph, as well as the block storage to OpenStack with Ceph, as well as object storage as a separate service, also with Ceph. And then also we have consultancy services, which is around these areas. Well, we did start this company as working with the academic sector, and they had pretty high demands coming to security. So we have kind of built this around 4 things. We have local presence, which is important for some customers that we have. And then we have the design, where the platform is designed with security in focus, and we run SE Linux on all the nodes, enabled everywhere. That is kind of hard work, but it's good. If you get it to work, it's good. And then we got segmentation also. We have separations between customers, also with SE Linux and things like that, and also TLS and all internal API calls and things like that, and as well as all data encrypted at rest. And for compliance reasons, especially for Swedish and Norwegian companies, of course, we are adheres to local jurisdiction and laws like GDPR and other things. So that's us, Safespring, that we now are demoing this SUSE platform on, and talk about SUSE a bit.
Yeah. What do we do? This is just a SUSE at a glance on the OpenStack part. So we are heavily invested in OpenStack as technology, and we provide our OpenStack distribution, SUSE OpenStack Cloud. This is a brag picture. We are good, we are big, and we are growing. So, and we always call ourselves the open source company. And what do we mean by that? Well, we true open source vision. Everything we do, we always push upstream. And when it's in the upstream, we can create products from it. So we always contribute to the upstream projects. That leads to zero lock-in for the customers. They can always move on. Regardless if they want to move away from SUSE or if they want to change their hardware infrastructure or anything, we are open to that. And we are heavily on partnering local partners and global partners, ISVs and HSVs. We're partnering with everyone, and we are quite open with it. So, and all our products and all our solutions are built on open source. So that's just a quick on who SUSE is. So I'm trying to find.
So how's the demo going?
Let's see. We actually do this live. I saw my colleague Simon Briggs did his presentation with video. He's the smart one. So let's see.
So what we're doing here, actually, we are setting up one admin node, which is kind of the administrative server that is going to provision the nodes in the Kubernetes cluster. So that admin node has special software, which will give us a dashboard from where we can add new nodes to the Kubernetes cluster. And the other nodes, what's installed on the other nodes is just regular, or this SUSE COS image. And we have not decided yet what they're going to be, if they're going to be master nodes or worker nodes. They can just be anything. That's something that we're going to decide later.
So I've logged into the admin node with my browser. And the first thing we have to do is to create an account. This is the main super administrator. So I will create that account. And we do not have a Kubernetes cluster bootstrapped right now, but what we do have is the installation wizard for this. And it doesn't matter if this is a physical hardware or if it's virtual machines. We decide what our internal dashboard URL is going to be, which is this, pre-populated. I can select to install Tiller, which is the server part for Helm charts. I can configure the overlay network. I can set the proxy settings. If we want to mirror our repositories locally, I can configure that. And I can also select what kind of container runtime I will run. So currently, we only support in production the Docker container runtime. We do have Cryo as a technical preview, and it will be released as production ready in next release, which will be soon. We do release a new version of Container as a Service platform almost every 6 months. So it's a fast development in this one. So when I've done that, I can also configure system-wide certificates in this part. So if we were going to do this on physical hardware, this is the only physical server I will install manually. All the others, I can point the installation to this administrative machine, and it will auto-configure it. Because we are using the cloud now, the OpenStack cloud, I actually did configure that in the cloud init when I bootstrapped the machines, so it's already done. So my other nodes are now registered as pending nodes. So they have pinged the administrative software and said, I'm a possible node for your Kubernetes cluster. Would you like to accept me? So anyone could install this, but anyone could not join the cluster if the administrator didn't accept it. But I trust this. I could actually go out and validate the fingerprint, but I do trust this because this is a demo. So what happens here is that the Vellum part, our dashboard, which is powered by SaltStack, so it's a SaltStack engine beneath that goes out and actually configure each and every node to be in the exact same software level as the admin node. So now I have 3 possible nodes. I actually named them as master and worker, but that's just for me to know which one should be master and which should be worker in my Kubernetes cluster. And this is a demo. In production, you will use at least 3 masters and a lot of workers, but
we could really make this complicated for ourselves and just pick the master node to be a worker node. It doesn't really matter.
It doesn't really matter.
It's just naming.
Yeah, exactly. It's just naming. So now I actually do select which physical or virtual node should be a master and which should be a worker. So I select that. And after that, I have to define the external fully qualified domain names for the dashboard and for the Kubernetes API. And now let's bootstrap the Kubernetes cluster. Again, SaltStack is now installing, configuring, bootstrapping Kubernetes in the background. This takes a couple of minutes. And hopefully it will go green checks everywhere.
And in the meantime now, because now we're just waiting. So if you have any questions about this, we're happy to take them right now. Otherwise, we can talk a little bit about persistent storage and things like that. Do you have anything?
Yeah, we do. Yeah, we have a question.
We have a question. The OpenStack is actually vanilla, but we are providing SUSE images and things like that as a partnership with SUSE. So the important thing here is actually that this container as a service platform will help you to set up Kubernetes on whatever, more or less. But it's our platform. We run this on. It's Safespring, but this we have with all the management things. That's the SUSE part, yeah.
So from a management point of view, this is the dashboard that you will keep the lifecycle management on the Kubernetes cluster itself, not on Kubernetes. So we actually do both patching the actual operating system underneath. We do patch the Kubernetes part through this graphical user interface. And we also do Kubernetes upgrades. So when we release a new version, it also comes with a new Kubernetes version, and we do a rolling upgrade of the Kubernetes cluster itself. We actually do provide the ability to treat the Kubernetes cluster, regardless if it's physical hardware or virtual nodes, as cattle. So you don't have to treat them as pets. So we actually do boot the node's root file system as read-only. And when we do an upgrade, it is automatically done. It's called transactional updates. We do a snapshot of the root file system. We install the RPM updates into that snapshot. And if it goes well, if RPM reports back that all the installation went well, it will flag that snapshot as bootable. And then when you want to apply the updates, you reboot the node, and the node will boot on the new file system as read-only. So all the nodes are treated as cattle. And if there are updates available, they will show up in this user interface, and you just press the update button.
But it's not very hard to get a Kubernetes cluster running. This is life cycle management of it that when it's getting complicated, because to get it up, well, and then it's time to upgrade, and then you get more work. So that's also what we are trying to solve here.
So just to save some time, I do have a script that adds a new node. Yeah, no, it doesn't add a new node. What it does, it creates a new instance in Safespring's OpenStack cloud, and I provided a cloud init file that will actually ping the admin node and say, I'm a possible node. So let's add that. Sorry, wrong script. That can work in the background. So it started to build a new instance. It should come up as CASP worker number 3, so it's spawning there in the background. So, yeah. And we will use that node as an additional node, just to show how easy it is to grow your existing Kubernetes cluster with additional worker nodes or master nodes.
And what's done there with the cloud init is just like, well, it takes some time. It's just like downloading the correct software version and things like that. So all the nodes are on the same pace when it comes to software. Any more questions?
So when it comes to persistent storage, you mentioned that earlier. We do support the Ceph, the NFS, and almost anything that is supported upstream in Kubernetes. So if you've got a volume driver, it's possible to use it in our solution as well.
And what about the etcd daemons?
Yeah. Good question. We got that earlier today as well. So we're repeating the questions. The etcd, we run the etcd on the master nodes. So we will only run your containers on the worker nodes, no control plane services on the worker nodes. Everything is done on the master node, except when we install with one master, which I have done. We need 3 nodes to create an etcd cluster. So we actually do run the etcd daemons on the 2 workers in this demo as well.
And there are some implementations where you would like that some people prefer to have master nodes and etcd as separate nodes. But as of this version, they're running on the master nodes.
Yeah, on this version, we do run them on the master nodes. But it's easy to expand the master nodes if you need more oomph in your etcd environment. So it should be up and running pretty soon. It is a live. There
Da,
you go.
da, da, da. Here it is.
So we actually have a working Kubernetes. Trust me, we do have a working Kubernetes cluster. So this super admin that I've created, I could download the kube config. Sorry. Server not found. How come?
You're in the admin. So it's there. Also log in.
I've seen this before. Yes. Sorry, I didn't catch that one. Yeah. I haven't run it either. Within I don't know if you got that question. Should I repeat the question? Yeah, okay. What's the difference between this and Magnum and Zoom? And yeah. Yeah, I'm sorry, I can't answer that. I have not run Zoom myself. This was created before that project, and within SUSE OpenStack Cloud, we do support Magnum, but you have to provide your own images. And Magnum is a bit behind if you compare to upstream Kubernetes. And our customers told us we need a solution that moves faster than the upstream Magnum. That's why we build the container as a service platform for them. So will it be? I can't compare them. I'm sorry.
That's all right. I was just curious as and see if you guys had looked at that and if it's similar, so to speak.
Yeah, we actually always do look at the upstream projects. We have released the container as a service platform as an open source project. It's called Cubic. So we do have an upstream version of this. And they actually decide how this should move on forward. So it's possible they will move on to that.
How are the demo god?
The demo god is
treating us?
Is not good.
Just the kube config file I would like to download in order to run kubectl. So that's.
I don't have. Sorry. I can't ping it. Let's see. This is perfect video. I'm sorry about that. Let's see if we got the right IP. 31. I did? Perfect. Remind me that you will get a gecko in our booth. So let's change that one then. On worker 2, you say 32.
Need to be sudo.
So I named them just because it should be easy. So
it goes to cost admin.
I'm sorry.
Of course.
I have to add that
The security groups.
As well. Sorry. Let's go to it. Was the work too, right?
We can just add the admin,
Work to
security group to that one.
Well, actually, I don't. Oh, I better do. You should be up here.
Just to show you how easy it is to change the roles. Wrong host. You're on.
Sorry.
Come on. That's most, yeah.
Thank you very much. I owe you one. So now I can access it. So I log in with the same
Credentials.
And I can get my kubectl config. And I just put it in my and there you go. Now I can work with my Kubernetes cluster as I should have done before. Never mind. So let's just deploy a simple service. If I get,
But we could also add first the node that we started. We can deploy.
let's just first apply is the name, right? So I've created a pod with 2 replicas. Let's just look at that one. It's a simple deployment of an Nginx, just displaying the host name. I've set the replicas to 2. So it should run 2 instances of that pod within my Kubernetes cluster. And if we actually do wide on that one, we see that it runs on the 2 worker node. One called master and one called worker node 1. So it's perfect.
Okay, we're running out of time here.
Oh, sorry. Let's go
but
back.
It's can you see the last one here, the node that we created?
So you see, there was a pending node showing up. That was the node that I previously added to the OpenStack cloud, and we can see that we have a new node here as well. I could expand my master cluster, which I will not do this time. I select as a worker and just click add node. So what this does is actually goes out and make sure that that node is updated and it's installed and joining the Kubernetes cluster as well. So if we had the time, which we don't,
we would see that.
We would see that. So I'm sorry about the mix-up with the name, but that's the live demo ghost, right? So it will come up as a possible node eventually. And as soon as it's up, it will be able to accept new pods running new containers.
Yes. Okay, thank you for your time.
Thank you, and sorry for the mishap.
Thanks.
Is there any question? Thank you again. I can come down the stage and bring you the microphone. Otherwise, we're gonna have a break now until 1:45. So enjoy some coffee and tea and so on. Thank you.